Hello friends, welcome to my YouTube channel Make Maharashtra. I hope you understood previous numerical. Now we'll move toward the second numerical. The change is only the cross belt drive. Everything remains same as like a previous numerical. So change is only it is a cross belt drive. So I'll read the numerical and write the given data as per the numerical. An electric motor running at 1000 rpm used to drive a motor rotating speed 500 rpm. Now of course the rpm they have given 2 rpm. So the bigger rpm it means more rpm it means bigger pulley. So bigger pulley is more rpm is smaller pulley, therefore I'll write small n, and smaller rpm is bigger pulley, capital N, correct. A cross belt drive is, here they have mentioned, a cross belt drive is used to transmit the power of 6.5 kilowatt. So I have mentioned here power. The belt speed approximately 12 meter per second. That they have directly given 12 meter per second. No need to calculate pi dn by 60, correct. Now the two shafts are located at 1500 mm apart. This will be the center distance here. For the material, the permissible tensile stress for the material is 1.8, that is sigma t, directly given 1.8, and the density of the material 950 rho. If the thickness of the belt is, now they have given the thickness here 6 mm, determine diameter of pulley, width of belt, that is B, length of belt, initial tension. Same procedure we need to follow, but keep in mind this is the cross belt drive here. Cross belt drive. So just draw the diagram. First step, given data is very important from your side. Write the given data, then draw the diagram of cross belt drive, and one by one we need to follow the procedure. First of all, they are interested in the diameter of pulley, correct. So VB is equal to pi dn by 60 into 10 raised to 3. So VB earlier we have calculated, but VB is known right now here. Pi also known, D also, small diameter of pulley don't know, RPM 1000 and 60 into 1000 will get the diameter of the smaller pulley, that is 230 mm. First point is over. First point is over here. Diameter of pulley we have calculated, correct, 230 mm. Second is width of belt, same. In previous numerical that thickness we need to calculate, now here width. So same formulation we need to follow. So first step, by using speed ratio is nothing but the ratio in between two pulleys, that is capital N means bigger pulley by smaller pulley rpm is equal to smaller pulley diameter, bigger pulley diameter. This I told you in theory. So smaller pulley rpm 1000. So they have mentioned here that 1000 by 500 is equal to 230 by D. So through which by putting the values in the equation we'll get the diameter, that is capital D 460. So here two diameters we got, that small d as well as a capital D. Then we proceed for width of belt. Now in case of the width of belt, we know this equation in which width is situated, that is sigma B is equal to total tension by B into T. Earlier we have seen. Therefore belt velocity VB is equal to pi dn by 60. Now earlier VB they have given, see carefully, 12 meter per second, but that 12 meter per second by which we are calculated the value of diameter, correct. At that time diameter was not known, now diameters are known, therefore for that we can calculate the velocity. This is called as a actual belt speed. Therefore VB is equal to pi dn by 60. D we have calculated 230. By putting the value we'll get the value of belt velocity 12.04. Earlier it was 12, but right now 12.04. So we need to keep as it is 12.04 for the further calculations. Clear? Second step, power need to be transmitted, that is P is equal to T1 minus T2 into velocity. So power we know, T1 minus T2 we don't know, and velocity. So we'll get the ratio, so we'll get the equation T1 minus T2 is equal to 539. Clear? Okay, next. Angle of contact. Earlier it was alpha because of open belt drive, now this is cross belt drive. therefore the sign is changed and sign is positive. See, sine units of d plus d divided by 2c. Just put the value, I'll get the beta, that is, it is in radian, 0.2321, correct. Of course you need to calculate in degree and then convert it into radian. Next will be the cross belt drive. Cross belt drive angle of contact is pi plus 2 beta. In open it is minus. So beta we have calculated by putting this value, will get 3.6 in radian angle of contact. Next will be limiting tensions. Limiting tension T1 by T2 is equal to e raised to mu theta. Mu is given, theta we have calculated, so through which we will get the value of T1 by T2 2.74, and earlier we have calculated T1 minus T2 value. So by comparing this easily we can put T1 is equal to 2.7 times T2 in this equation, correct, through which we will get the T2 first. So T2 is, I will directly tell you, T2 is this slack side 309 and T1 is 849 Newton. Clear? I don't think from my side I will explain where it is situated. I told you that two equations are there, T1 by T2 ratio and this one be there. So I will put the T1 value here. By putting this value I will get the T1 and T2. Clear? So these are the two values, 309 and 849. Next I am using centrifugal tension, same equation, that is, just I will zoom it. Now see, Tc is equal to mass is equal to density into volume. So density rho into Bt divided by 10 raised to 6 into velocity. So I'll put rho value is given, B value is not known, we need to calculate, thickness is given 6 and velocity which we have calculated, actual velocity. Therefore Tc is in terms of B, correct, width. We know the next equation, T1 is equal to total tension is equal to T1 plus Tc. So by putting this value, again the iteration will not be round figure because we don't know the value of B. Clear? Then we move toward this part, that is maximum tension, in which B and T is available. Sigma T, tensile stress, is equal to total tension divided by B into T. So total tension we have calculated in this term and B into T. T is known, tensile stress also we know, through which we have calculated the unknown one, that is width, that is 85 mm. Clear? This part is over. Diameter we have calculated 2 diameter, width we have calculated. Now we move toward the length of belt. Now length of belt, this is a cross belt drive. So cross belt drive, directly using the equation you can see here, L is equal to, this is cross, plus sign is here, L is equal to 2c plus pi into d plus d divided by 2 plus d bracket square divided by 4c. By putting the value, length of belt, that is cross belt, is 4163 mm. Third part is over. Now then they have asked to calculate initial tension. Now initial tension, before that we must do the centrifugal tension. So Tc is equal to 0.82 sigma b, which we have calculated here, this, and just putting the value I will get the Tc value, and through the Tc value I will get round figure value right now, because by putting the value of B, this equation, by putting the value of B we know, we have calculated. Therefore initial tension is equal to T1 plus T2 divided by plus 2 Tc divided by 2. Initial tension is equal to T1 plus T2 plus 2 Tc divided by 2. Tc value we have calculated, we have put, therefore initial tension would be will be 650 Newton. So likewise we need to solve the numerical. So same, we have covered all the things which they are required, that is diameter, then length, width of the belt, length of belt, and initial tension in the belt, that we have calculated in this numerical. Clear? Likewise you need to solve the example. Many times they will ask the thickness, they will ask the calculate the width, so you need to focus what are the requirement. Clear? So I will revise this session, what we have covered by the steps. Now this is the cross belt drive numerical. First of all, from the given data it was clear Then follow the sequence. They are interested in first diameter, so diameter, 2 diameter small d and capital D, calculate by the speed ratio and velocity. Then width of the belt, we can calculate as like a thickness, that is first of all actual velocity, then power transmission. After transmission, angle we need to calculate. For the cross belt drive, plus sign is here, so therefore angle of contact is this much. So T1 by T2 ratio we have calculated, and that T1 by T2 ratio is compared with this T1 minus T2. So by comparing this, we'll get the T1 and T2. So T2 is 309 and T1 is 849. Of course, tension on tight side is always more. Then centrifugal tension, we have seen the mass is equal to density into volume. By putting that value, we'll get the TC value in terms of width. Now sequentially we have used total tension is equal to T1 plus TC, so that is again in terms of width. Sigma T, tensile stress, is equal to total tension by area, that is B into T. Now here B is only unknown parameter that we can calculate easily. Next will be the length of belt, the cross belt drive, direct formulation, plus sign is there, number of time I am telling this, clear? So keep in mind. So length will be the 4164 mm. And then they have asked for initial tension. Initial tension equation we know, here TC we don't know, that's why TC value we have put, because we have calculated the value of width, and by putting this value TC is 706.70.65. So just putting this, we will get the initial tension 650 Newton. Clear? So do the practice from your side. Thank you.